to this video of the series BPMN in Action, and today we look into a specific industry, the insurance industry. Besides that industry, we are also focusing on decisions in BPMN. Therefore, we are going to learn a new standard decision model and notation, DMN. That's also a standard maintained by the OMG, the Object Management Group. That's the same organization that's responsible for BPMN. And BPMN and DMN go hand in hand, and today we are going to learn why. My name is Nele Uhlemann and I'm a developer advocate here at Camunda, and if you know me from previous videos, I like to bring my horse, but for this video I brought my bike, because if you are biking, insurances can be very important for various reasons. We come to that a little bit later. Let's have a quick overview what processes mean in insurance companies. And on the business side, we can imagine in an insurance company, we have a variety of processes. For example, we have customers that apply for an insurance. We maybe have customers that request insurance coverage. Also, if we are the insurance company, we want to make sure that we have a process for recourse in place if that is needed. Also, we can think of that we don't offer just one insurance, but we might have different type of insurances. So we have a variety of them. Meaning maybe we have a car insurance, an animal insurance, a building insurance, all sorts of things. And often our processes will involve complex decision making. For example, if we have the application of a new customer, maybe we want to perform a risk analysis of that customer. And doing that could be more complex and could involve more complex decision. Also, if we want to detect fraud, that also could be a case for a more complex decision we need to make. On the other side, we have the process automation side in insurance companies, and here we have often different software components that already support our business process. We often have the need for flexibility due to regulations, but also maybe we need to adjust the process due to business needs. And if we look into the sector of insurances, that is a relatively old business model, so the idea to sell insurances is not brand new. That means often in established companies we also find older IT architectures, or at least we have to deal with older components and maybe we want to modernize them. This said, BPMN already is really well established in that industry due to the possibility to automate BPMN directly. So having BPMN on the one side to document the process, but also on the other side to have really the end-to-end automation of a process and the service orchestration of different components makes BPMN quite powerful for this industry. Let's have a look into a concrete process and see also how we can link DMN and BPMN together. I'm here in the Camunda web modeler, but to follow this tutorial you can use any tool that you like that allows you to model BPMN. You can also sign up here for this tool and start modeling right away. I already created a folder, I call it Insurance Project, and now what we want to do is actually create a process. And I had that into the introduction. I was recently biking in Canada, so I was not with my bike, but I rented a bike, and unfortunately after 10 kilometers I got hit by a car. That was not so nice. Fortunately I was not broken, but the bike was broken, and I was wondering, in this case, would a liability insurance of that person cover the cost to repair the bike? So the process we want to model here for the insurance company is actually the request of insurance coverage, and that also would be our start event if I zoom in. So we could say we insurance coverage requested, and the happy end or the end pass could be that the coverage is granted. And maybe as a first step what we would do is we would check the insurance plan, and if the cost is covered, we are one step closer to our happy pass, we are one step closer to the end event, but there could be also maybe the case that the cost is not covering the insurance, and we would need to include another end event where we would say that the coverage is denied. Cool, and that would be the no. I will model this process quite quickly and we will talk in a few minutes over it. Cool, perfect. That's a diagram. I zoomed out, so this is a great overview. You saw here some things are popping up. Don't worry about that because the web modeler is connected to Camunda's AI workflow engine. That means you can deploy diagrams from here and automate them directly. And those errors give you an indicator that this diagram is not ready for automation, but we can basically ignore it and collapse it here and have the ready diagram that we can see. And let's quickly go through it. We had this here already, the check the insurance plan. Here we have a decision type of damage because depending on that we might have different costs associated. Then we have a fraud check as a task, and if we have no fraud we can cover the cost. If we have a fraud we would reject it, and maybe there is a maybe case where we need to perform an extra check, where we maybe need extra information. I can make that a call activity. Just a reminder, that means I reduce complexity from that process. That might be a single process or an extra process I'm calling. Also call activities can be used for reusable things, so that's always a good idea. And then after the extra check I'm hopefully able to answer the question if the insurance cover the cost or if the insurance company is not covering the cost. Okay, cool. If I go back to this process, what I don't like here is that I have three decisions. I have here the check plan or check the insurance thing, I have the type of damage, and I also have the fraud decision. And I really don't see how those are related to each other or if they're building up on each other. That's one part why BPMN might not be the best idea for modeling decisions, because you cannot completely display all the relations between the decisions. Also, you can imagine if we would have more outgoing sequence flows, maybe there exists more type of damage, this diagram could become easily way too complex with too many sequence flows. So a good idea here is to put the decisions into a decision requirement diagram called DRD, and behind each decision have a table implemented called DMN. And what we have to change in our diagram is basically quite easy. What we can do is we can remove a bunch of things. So we can remove this and this and even this, and we maybe just have one thing here because we just have one decision where we say we check the cause, and then we can say cause can be covered, and we change here the logic. We say here is a yes and here is a no, just from the label perspective, and that way we made the diagram already way smaller. And in order to make visible that we link to a decision, what we can do in BPMN, we can use task types and change that here. I zoom in, so change that here to a business rule task, and that way we know there is a more complex decision behind it. Cool. In the next step, we are going to build our decision. So we are going to build the requirement diagram, and then also we are going to implement the tables. I go back to my folder, and here I can now create a DMN diagram, and we are here at the check cause. That's how we can name it, and that's actually maybe also the last decision we want to make here is check the cause. And the other boxes we had in our BPMN diagram, we are bringing back now into the decision logic. So if you remember, we had this check insurance plan, And we also had one that was calculate cost. And we can now outline that those decisions will be input for our last decision. So here already by doing this, we can define relations that were not really visible in our BPMN diagram. And we can even do more, and we can be a little bit more concrete here. So we can also define input variables. It's just, again, for readability at that point, but we can, for example, say what we need to know here is the cause of damage in order to check the insurance plan. So maybe if a horse caused the bike damage, our liability insurance would not cover here. And here for the cost calculation, we can also say as input variables, maybe what we need is here the value when new. Also what we had in our diagram was the type of damage that could be important for our cost calculation. Maybe also what we need is, let's say, the age of the object. And maybe as a last indicator, if we have repair costs, maybe we also want to have repair cost. And also for the last table, what we need is here for the check cost, we have now the cost and we have the insurance plan, if the insurance plan covers the cost. What we might be also needing here for the fraud detection is the object itself that we want to have. And with that object, maybe also what we need is the relation to damaged person, just in case it could get interesting. Sorry. Cool, and this is our decision logic, and now we can easily see in the business logic how the decision is built, like what is part of the decision and how the decision will be made in the end if we include the check cost table here. Let's dig into one of the tables if we go to the check insurance plan here. What we can see here is the input column, and when I click on it, I can define it, and here we can say cause of damage. And what is a little bit different here is in BPMN we have the property panel to add technical attributes. Here we add them in the table, so the expression will define the variable name. We have a string, and yeah, we can say maybe the cause was a car, maybe we have the animal cause, maybe we also have something related to a building. And yeah, if we have those things, what we want to have as an output is an insurance covered, and we can have here an insurance covered as a boolean. And for example, the logic here is if we define one new row in our table, that is one new rule. And if we go for car, animal, and building, that has an OR logic. So if one of those is matching, actually, we would say the liability insurance in this case would not cover, so we have a no. And in the case when those are not true, we would have a yes. So if those are not met, those requirements, then we would cover. What is really important here is the hit policy. So this is a way to read the table, and unique actually would not work here in this case because we need to make sure that just one rule can apply. And for example, if we now have the car, both rules would apply. The first one would apply, but also the second one, because in the second one we said no matter what, it will be true. So if we have this during the runtime, unique will create problems and a runtime error basically. We can change that here to first. That means the first rule that we meet in this table will be the one that will be applied. And in this case, it works perfectly. So we check for car, animal, and building. And if one of those are there, we would always say it's the liability insurance is not covering. If none of them is there, we always go for a true case. Now you can see the table is still quite simple, but it can be sometimes really beneficial even to have small rules in tables, because rules might get more complex, and also for the visibility it's easier to understand what's going on than putting everything into a single table. Let's go back to our DRD. Okay, in order to not model all the decisions, I already created a table here with or a DRD with the other tables, so we can expect the other tables. What we can do now is, if we go to calculate cost, what we see here actually is that we have more input values that we want to evaluate, and we have an AND logic. We also see that here. So in this case, we have the type of the damage, which could be total, repair, or person, and then we have an AND logic, and here what we can see as a type, we have a number. So we can also have something during the runtime where we put the variable name here, and then this gets evaluated. And what we basically do in the end is we calculate here with our values. So we put in the value, and we have a 5% loss of the value for each year. Of course, that could be more complex. For a person damage, we could say we have also more complex rules, but I just said I had coded or hard typed in here it's a 10,000 always, just in case. And here actually unique works quite well, because what I want to make sure is that I have either a total, repair, or a person. So this is quite good. And let's have a look into the last table. If we go to the check cause, what we can see here is we have again a first hit policy, and we take the input from that table, from the insurance plan. What we see here, the insurance coverage, if that's true. We will have some rules around it, and we also have the cost here as an input variable that we also want to evaluate for our last rule. And what we have here, of course, the insurance coverage needs to be true, but if we have a cost that is over 5,000, we maybe always perform an extra check. Another rule could be if the coverage is granted, if we have something related with mobile phones and family, that maybe also gives us always the extra check. And so we could continue defining rules. We could also say, and I just make that a little bit smaller because of the video, what we could also say is if the insurance coverage is here true and a value is always under €100, we always go here for yes. And if we have something that cannot be covered, we always have, of course, a no. And we have not and if we have not defined any rule that is met before, we always go for a yes pass. That could be something how we could model the last rule here. And if you remember our BPMN diagram, we had exactly those outputs on the sequence flow. We had the maybe, we had the yes, and the no. So this last table actually is the one that we would like to connect with our diagram. And we are going to do that in the next step. Let's go back to the DRD, and what we need here actually is now the properties panel, and we have here an ID that's a check cause ID. And I basically copy this one here, and I go to my project, and I go back to the BPMN diagram. And here, if I go to the BPMN table, I make that a little bit smaller again because of the video. And what I can do here is the implementation. I go for the DMN decision, and the called decision could be then here the check cause. That's the ID that we just copy and pasted, and that's basically all I need to link the decision to the BPMN diagram. And by doing that, also the other rules will be called. Cool. In the next step, let's take care of automation. So what we also need to have is a result variable to store the maybe, yes, and no. So I can copy that, and for the automation, what I need is now I need to define expressions here. I do that quite quickly, so I can say if the cause is here a yes, and also here we evaluate this again. So if we then have a yes, here we have a maybe, and here we have the no, and also here after the extra check we might get a different indication. That is a no. after the maybe. And because I would like to deploy it quickly, oh, there's one gateway I missed, we don't need that there. I'm going to implement those two as manual tasks because we don't need to provide any extra code logic here. The token basically will just go through, and in this maybe case I'm going to change that to a user task because that also means we can see it in the task list. We don't need to provide any code here, and by doing so I should be fine. And now I can also, or I should give it a good readable name. So I could say this is a request insurance coverage, and then I also name it here request insurance coverage. Perfect. And now I'm going to deploy the diagram, and that is deployed. I go to the folder, I go for the DRD, and I also can deploy here the DRD. And in the next step, we can start an instance of the deployed diagram and step through it. Perfect. After deploying the diagram, we can start a process instance quite easily from our BPMN. So let's go here and start an instance. What is important here is, of course, we need to provide all the variables that are needed to evaluate our decisions. And we can start here the process instance by defining a JSON. I zoom a little bit in, I prepared already something. So coming back to my case, we know that this damage was caused by a car. The type was repair. The object value maybe around $2,000. The repair cost, I remember that quite good, was just 10. And then we have things like the age of the object, and the relation. And I can start the instance now. I can see here it was started, and now it will direct me to operate. That is a tool to observe the runtime of your processes, but also you will be able to see history. And in this case, our instance just went through. So what we can see here, the path that was taken. I also can now go and click on the decision and go here to the decision and see that we had a false here, and that's why we took the no path. I also can see and try to understand where it come from. And here we see actually, we had the car variable. That's why we evaluated in this table to the false value. We could also see the cost calculation here. We basically took the repair costs. And that basically led to the output that we will not cover the repair cost that was due to this cause. I hope you liked the video and you learned something, and you hopefully learned how to combine DMN and BPMN. And leave a comment to tell us what you like to see next. And also, if you have models you like to share, visit the Camunda forum. We are always happy to have a look. See you the next time.